To implement the chain of responsibility pattern, first we need to introduce our handler class. So let's add a new class called handler. Each handler should maintain a reference to the next handler in the chain. So here we need a field of type handler called next. Now let's generate a constructor to initialize this field. So there you go. Next, we need to declare our handle method. As I told you in the last video, this method should be abstract because at the time of implementing this class, we don't know how to handle a request. That is something that we need to determine in our concrete handler classes. So public abstract void handle, which takes an HTTP request. Now, because we have an abstract method in this class, we should mark this class as abstract as well. There is just one more piece here that I didn't talk about in the last video because I didn't want to confuse you with too much detail. Basically, we need a template or a blueprint for handling requests. In this template, we're going to have a concrete handler handle our request. If the request is completely handled, then we're going to stop processing right there. Otherwise, we're going to call the next handler in the chain. So we can implement that logic, that template in this class. To do that, I would prefer to rename this method to doHandle and then create another method called handle. So in this method, we're going to call the abstract doHandle method. This is our template method pattern. So doHandle this request. Now, we should change the return type of this method to a Boolean because we want to know if the request is completely handled or processed or not. So if this method returns true, then we're going to stop processing right here. Otherwise, we're going to call the next handler in the chain. So next dot handle, and we give it this request. Now it is possible that this handler is the last handler in the chain. So before calling the handle method, we want to make sure that the next field is not null. So if next is not null, then call its handle method. So this is our blueprint. This is our template. Now in our concrete handlers, we need to implement the doHandle method. Okay. So let's change our authenticator class and have it extend our abstract handler. So extend handler. Now let's press Alt and Enter and implement the abstract method in the handler class. That is our doHandler. So we can simply move this logic to this new method, like this. Okay, now we no longer need this method. So all our handlers have a consistent interface. This is another benefit of this pattern. Now, we have a compilation error saying there is no default constructor available in the handler class because in this handler, we created a custom constructor that takes the next handler. So we don't have a default parameterless constructor. And that is the reason why the Java compiler is complaining that when creating an authenticator object, we don't know what to pass to this handler constructor. So to solve this problem, we press Alt and Enter and create a constructor that matches the constructor of the parent class. There you go. So in this constructor, we get the next handler and we simply pass it to the constructor of our base class. Okay. Now let's apply the same changes to our compressor and logger classes. So here's the compressor class. First, we have it extend the handler class. Now let's implement the abstract method. Now we're going to move this logic over here. So here we're returning false, which means we're not done processing or handling the request. And that means the next handler in the chain should be called. Okay. Now let's remove this old method. We also need to create a constructor for getting the next handler in the chain. There you go. So we're done with the compressor class. Before we move on, I think I made a mistake in the authenticator class. In the doHandle method, we're returning the value of the isValid variable. So if this request is sent by a valid user, we're going to return true. That would stop the processing of this request. So the other handlers in the chain are not going to be called. To solve this problem, we need to apply the not operator here. So if this request is sent by a valid user, we're going to return false, and that means the next handler in the chain, which is our logger, is going to get called. Now the final change. We should go to our logger class and have it extend the handler class. Let's implement this abstract method and move this statement over here. Once again, we are returning false, so the next handler in the chain gets called. Now, we no longer need this method, and finally, we should create a custom constructor. Beautiful. So all our handlers now follow a consistent interface. Next, we should go to our web server. Instead of talking to concrete handler objects, we're going to maintain a reference to the first handler in the chain. So here we declare a field of type handler. We call it handler and initialize it via a constructor. Now let's move this field over here. Good. So here's our constructor where we pass the first handler in the chain. Now finally, in the handle method, we're simply going to call handler.handleRequest. Now obviously in a real application, we should have an if statement here and make sure that this object is not null. In other words, a web server should have at least one handler. Okay. Now let's go to our main method and see how we can bring all these classes together. So main, let's imagine we want to build a processing pipeline like this. First, we have our authenticator. Then we have our logger. And next we have our compressor. So the compressor is the last handler in the chain. I'm going to create this first. Compressor equals new compressor. And by the way, we have two compressor classes. Here's the one that we created in this section, and here's the one that we created when I talked about the strategy pattern. So here's our compressor. This is the last handler in the chain, so we should pass null over here. Now, before this compressor, we should have our logger. So let's create a logger, new logger. Here we should pass our compressor as the next handler. One more time, we should create our authenticator. So authenticator equals new authenticator. And here we pass our logger as the next handler in the chain. So now that we have built a chain of objects, we can create our web server. New web server. And here we're going to pass our first handler, which is our authenticator. Now, let's call server.handle and create an HTTP request object over here. Here we should pass a username and password. So let's say admin and 1234. This is considered to be sent by a valid user. So when I run this program, we should see each of these handlers handling the request. Take a look. So first we had our authentication step. This request was sent by a valid user. So then our logger kicked in and logged the request. And finally, we compressed the request. In contrast, if I pass an invalid user here, the logger and the compressor are not going to get called. Take a look. There you go. So we stop processing right in the authentication step. With this structure, we can easily disable one of these steps or add a new step. For example, if I want to disable logging in certain scenarios, then we don't have to create this logger object. And we can have our authenticator point to our compressor like this. So let's pass a valid username and password. There you go. We no longer have a login step. This is the beauty of the chain of responsibility pattern. Our system is open to extensions and closed to modifications. To model this scenario, I didn't have to go to our web server and change the implementation of the handle method. This is open for extensions. Similarly, we can add a new step anywhere in the chain. For example, we can add a new handler called encryptor that extends our handler class. Let's quickly implement this abstract method. Here we're going to print encryption. Let's also create a custom constructor. Beautiful. Now back to our main method. We can easily add this step after compressing a request. So our pipeline is going to look like this. Encryptor. Now we don't have a logger, so let's delete that. Let's create an encryptor object. New encryptor. This is the last object in the chain, so we pass null over here. And then we have our compressor point to this encryptor. This is our new pipeline. Now let's run the program. There you go. First, we authenticated the request, then we applied compression, and finally, encryption. So with this pattern, we can easily build processing pipelines that follow the open-closed principle.